Hello everyone, this is Ari from Pantech. So in the previous session, we have configured this LORA with the HTML32 to send the data. So from our STS sessions, we have getting into the project, guys. So we are going to see this 7 days in the project. We are going to spend these sessions in developing the project. So from starting, we are going to give the introduction to what are the sensors we are going to do use and what is the project we are going to design is we are going to design a smart agricultural system. Okay. So STM32 is the main controller and we are going to use the secondary controller as an ESP32. So what is this project is we are going to do is we are going to measure the temperature sensor values and we are going to measure the humidity value and we are going to measure the soil moisture value. And as per the soil moisture and the temperature sensor, as per the soil moisture reading, it is going to supply the water automatically to the crops. Then as per the temperature sensor, it is going to use the sprinkler motors, so which will when the temperature increases at the maximum limit the sprinklers so it will be tuned on. So what it will do is it will sprinkle the water to take care of crops. Okay, so this will make the application in a smart way. And what is the use of ESP we are what is the use of ESP we are using with it? What is the reason is so our agriculture farm will be in a long distance from our house. Okay, so it will be ranging from we can consider a scenario. It is from ranging from about 7 to 10 kilometers. Okay, so what I have to do is now in my farm there is no cellular network or Wi-Fi network or anything, or there is no capability of network reaching that. Okay, but my house has my home has Wi-Fi router, so I can connect this. I can connect my ESP32 with this Wi-Fi router. So what I'm going to do is we are going to use this main controller. We're going to place this main controller STM32 in the form. What are the things we are going to interface it with this? We are going to interface the DHT sensor, which is a digital humidity and temperature sensor, and we are going to use this LORA module. So I will come after why we are going to use the LORA module. So then we are going to interface this soil moisture sensor, and we are going to interface this LORA. So what is the reason for LORA is, and we will also interface the LORA with this ESP32. Okay. So what is this? What is this going to do is the STM32 will continuously read the data of the temperature and soil moisture, and we are also going to connect this water pump with this STM32. So the motor will be the water supply motor will be controlled by the STM32 one. So now why we choose this STM32? First we have to know that. So before getting into the project, we have to know why we are choosing this STM32 and what are the reasons. So in the starting session itself, so starting of the masterclass itself, we have seen this lots of features. So what is the main feature is? One is low power mode and another one is it is scalar. So I can use what I can develop the board. I can get the board from the STM controllers as per the requirement. I don't need all the features like DAC and UART, DCMI like this, all the features. I need only some of the features and I can scale it. I can reduce the size and I can reduce the cost and I can reduce the battery power. Like this, we can do lots of things with this STM32. That's why we are using this STM32 for those things. And what is the role of this ESP32? So what we are going to do is with ESP32 is, so as I said, we will not get the network or cellular data in the farm. So I need to transfer data somewhere, right? So the user have to see the data or he have to operate it by the mobile phone or smartphone or a PC. So what we are going to do is we are going to use this. We are going to connect the LORA receiver with this ESP32, and we are going to connect the LORA sender with this STM32. So what it is going to do is it is going to send the data from all the data, soil moisture data and temperature data, all the data to the what is the pump state, what is the time of the pump is running, all these data to the ESP32. So what does the ESP32 is going to do is it is going to connect with the AWS cloud and it is going to update the data in the cloud, and by that we can see this data in the PC or a smartphone, and we can also operate the pumps. So we can also set some of the features as in the smartphone. So we don't need to change the setup on the STM32. So we can control it by the smartphone. So that is the concept. And what are the things we are going to add it with the ESP32? Now we will see. So what are the things we are going to add is So this STM32 is going to be in the farm, right? Agriculture farm. So this is ESP32 is going to be in our house. So what this ESP32 we are going to develop is we are going to develop both the systems, smart agriculture as well as smart home automation. So what is we are going to do is smart home. So what is we are going to do is we will read all the readings from this STM32. So we are going to send those data to the cloud. So this is a first step of process. What is this ESP32? So we have a ESP32. So it is a powered chip, like so it is a good powered chip. So we can create we have lots of features in ESP32. So we can do some functions. So what is the thing we are going to do is we are going to create a smart home system in this using the ESP32. So what are the things we are going to connect is we are going to connect the GLCD. We are going to check whether we are going to check the smart light system. We are going to implement smart light system in the CSP32, which is going to tune on and off the light and control the electricity. And we are going to add. We are going to again we are going to read this temperature and humidity sensor, temperature and humidity inside our house, and we are going to add this components also, and we are going to add this gas sensor, and we will have this buzzer. Okay, we are going to add the buzzer. If any fault is occurred in the STM32 means it is going to send the data to this ESP32 in the mode of LORA by using the long range LORA. So if any fault is occurred means it is going to STM is going to send this data to the there is a fault occurred in this STM32, so it is going to send the data and the buzzer will be activated. So buzzers we can use it with lots of things, like for the buzzer will be activated for the gas leakage, or it can be activated for the STM32 error, or it can be the buzzer can be sounded for this water level indicator. So we are also going to add this water level indicator for our home. So now you can see we have solved the two problems at the same time. So we have used this STM32 to use this smartphone, and we are receiving the data from the STM32, and we are going to upload it cloud by using the second controller, which is the ESP32, and we are not going to do the simple thing around. We are going to add convert this ESP32 to the smart home device, and we are going to control all the home appliances and the systems. So this is a project. So in the we will develop these related projects and we will get into it. Okay. So in STA class we have seen this introduction to this LORA, right? And we have created the code for this LORA. So we already created this code for sending the data to this LORA receiver. Now what we have to do is we have to receive the data, right? So we have to receive the data from ESP32 from the using the LORA receiver. So what I am going to do is I am going to receive the data from the STM32 using this LORA. So for that we have to program this ESP32 also. So what today we are going to see is we are going to program the LORA receiver using the ESP32, and we are going to see this output. And what is the next thing we are going to do is we are going to get into this DHT11 sensor. So what does DHT means? It is a digital humidity and temperature sensor. So we are going to interface this with this STM32. So this is the thing today we are going to do. Okay. So before developing the code for ESP32, now we will get into. So before getting into the next topic, now you can convert this masterclass into an internship, guys. So it is in a 1 month internship on embedded systems. So we are already learning the STM32, which is based on ARM Cortex M4 in a register level, right? So we are learning like in a register level. So it will be very much useful for you. So you can you have to when you have to improve yourself, you have to practice on these things. So while practicing, you need some internship like reference, like what are the ins, what are the bugs, all things you have to need some reference, right? So for that purpose, this internship is provided. And in what is the benefit of this internship is lots of topics you can refer to this internship, and lots of things going to be added in this internship, like CAN, LINs, lots of communications and tax core concepts all coming on the pipeline of courses. So so don't miss this opportunity. Our fees is 1,200. So our discount price is 599. Okay. So you can use this ESMC1 coupon code, and by using this, you have to pay only 691 only. So by paying this fees, you can register for the internship and you can get more benefits. Okay. So now we will get into what are the benefits you will get. So as I said, so we are practicing lots of codes, right? So we are practicing lots of codes in the live session, and you are developing lots of core concepts. So you have to practice yourself for making to upskill yourself, right? So when you are practicing, you will come with some errors, or you will have some doubts related to those things, or you will after executing the code, you will not get output like this. So for that purpose, you can refer to these 30 days videos. So what is the best benefit is the 30 days of masterclass live sessions will be available as a recordings in this internship. So and lots of topics also going to be added to those videos. So it will be accessible for those recordings will be accessible for 90 days. So you can use those videos as a reference for hands-on practice and developing a while developing a code. And even the concept is you are not clear with the concept means you can again rewatch it. So the concept will be get clear. Okay. So and what is the next benefit? So next benefit is we are going to do lots of hands-on practice on embedded projects, and you are going to implement what is the project I have teached you, and you are going to implement those in real time by yourself. So while developing the project, you will get lots of errors and lots of bugs. So you can in this internship we will provide a lots of practice on embedded projects, and you can ask the questions to clear the doubts to myself as a me. Okay. And what is the next benefit? So next benefit is you will get a 30 days of download presentations. So I am giving a presentation right for 30 days. So you will get this. Plus additionally, what you will get is what are the things we are using. We are using data manual, reference manual, programming manual, user manual, lots of things. So those are all the things what are we are using to develop the code, and all the things we use to learn the code concepts and communication protocols. All those files also will be included in these 30 days of downloadable presentations. So you will get the presentations as well as what are the things we are using for developing code and the projects. And also in addition, you are going to get a codes that I am developing. So I have developing a code in live sessions, right? So those codes are going to be .c files. It will be shared you as in a format of .c file. So you can refer to those codes also. So that will be exclusively available for these internship students. So you can you can get those codes also. So you can use those codes for reference also. Okay. And what is the next benefits? Is we will have a one-to-one live sessions. So what is this? Is you can interact with me for 1 hour every Saturday class. So you can ask the doubts. You can clear the doubts related to the topic which I have taken from the day 0 to till the date, or even you can ask the doubts related to the embedded systems out of the topics which I have. Now I am taking STM30, right? If you have a doubts related to the other microcontrollers, or you are doing lots of or you are involved in other embedded projects, you have a doubt related to those projects, or you have doubt related to this other microcontroller means you can also use those mastermind class to sessions to ask the questions related to the out of the session also. So you can ask the doubts related to the embedded systems out of this STM32 also. So you can use this mental life as these opportunities. So this is about how you are using your this opportunity, how you will make use of it. So you can also you can ask me to, you can also prefer me to do and take some new topics some topics some core concepts you like to be learned, right? You would be want to learn those concepts. So you can say it in my Saturday class to me directly, so I can prepare on those topics, and I will be giving a presentation in this internship. So it will be very much exclusive for the internship students only. Okay, so those even out of the topic, not based on STM. If you can ask, if you want other topic more than out of this team, you can also ask me that. So you can prefer me that. So I will take this. I will get into the topic and implement those things, and I will be giving you a recorder session for you, and also I will give a code on developing those things and implementing in a real time. So these are the benefits you can get by this internship. So this is about how you are using this opportunity. Okay. So next is after registering, you will get an internship confirmation letter. So after registering, you will get a confirmation letter, and you are going to get a 2 e-certificates. What is this benefit? So you can use this certificates in the resumes. So what is the benefits? Is we are learning STM32 based on ARM CM4, which is an industrial based controller in a register level, right? We are not using a advanced library, all libraries, or some things which will be very much easy like Arduino programming. So we are getting into a register level. So it is in a from 0 to ground. We are starting from ground to advanced, right? So this is a basic step. So we have to know about registers to develop the all GPU like drivers. So we are learning HTML2 in register server. So this certificate will be very much useful for you. So what are the two certificates we are going to give? We are going to give two certificates. One is for participation and another one is for course completion on this HTML2 register level. Okay. So it will be very much useful to you. So the internship fees is 1,200. So don't be afraid. So you don't have to pay this full amount. You can use this ESMC one coupon code so that you can get this 509 discount. And the discount fees is 691. Okay. So you can get the internship at 691 only. So this is the registration link, guys. This registration link will be available in the chat box. You can see this, and or you can see this description box. In the description box, there's a registration link will be available. So join as internship user and use this internship as a upskilling opportunity for you. Okay. So we will get into the concept. We are going to see this. So the Pantech e-learning is offering a 100% placement for your students who was trying to get into the embedded engineering domain or Python domain, Java's data science domain, artificial intelligence, and electric vehicle engineering. So these are the domains we are focusing on. The Pantech e-learning is focusing on these domains and providing a 100% placement for these domain-based industries and companies. So guys, you can enroll for this link, and link will be provided in the description box and as well as chat box, or you can also use this QR to scan and enroll. So you can join our team. Want to make a career as an whatever domain you needed. So what is the thing we are going to do here is we are analyzing the industries around us. So we are seeing what are the technologies they are asking from the students. What is the technology they have the industry required. So what is the technology that the industry needed. So we are analyzing those things, and as per the industrial requirements, we are training the students, and we are teaching them how to attend the interview and all the things, and we are giving them a 100% placement on based on the domain core industry. So if you take embedded, you will take a scenario of embedded engineer. So you will get a placed in the embedded domain. So the training is going to be based on the what is the as per the industry's requirements. So what are the technologies they are asking from the students. So those technologies going to be teacher going to train you for the this course for up to 3 to 6 months, and we are going to we are going to make you placed in this your dream companies. Okay. So guys, don't miss this opportunity. So you can enroll this. So enroll as soon as to get this. Lots of offers are going on. So you can enroll. Who's getting first will get the best offer. So register this and get a best offer and get placed in your dream company. Okay. Okay. So first we will create this code for receiving LORA. Okay. So what are the things we have to do is first we have to add this SPA. Why we are adding this SPA package means the LORA is communicating in the communication of SPA communication, not in UART. So there are lots of variations in LORA. The LORA will also communicate in UART communication in different series. I am using LORA series. It will communicate in the SPA communication. So when it comes to the ESP32 and Arduino, there are lots of inbuilt libraries, so it will be very much easier for developing. Okay. So first we have to include this include of SPA communication dot h. So this will add my SPA communication. Sorry, wait. What is the next thing you have to do is we have to add this LORA. So for adding this LORA, you have to first install this LORA package. Go to this library and search for LORA. Okay. So you can see we have lots of packages. I have installed this one and this by Sandeep. Okay. So this one. So you can also install these libraries. So first you have installed it. I have already installed it. Okay. Then we have to include this path. Include this LORA. Okay. So now we have include these pins. So what is the next thing we have to do is we have to define the pins. So when we are configuring this SPA and the LORA included, it will automatically configure this pins of MOSI and MASO, and these two pins are automatically configured by this LORA library. But we have to set these DIO 0 pin and reset pin and save select pin. Okay. So first we will do this. First we will define these pins. So first define the slave select pin. So I am connected this slave select pin with my ESP32 15th pin. So I will do it as 15. Next we have to define this. Define as RST reset pin. So we will write my RST pin is I connected is it is 4 in ESP32. So guys, for connections you can refer to the Google or you can refer to the pin notes. So when you see this ESP32 pin notes means you can see what are the pins having the SPI communication and you have to connect with those pins. Okay. So define. Next is DAO. So this is going to give a this pin is used for generating an interrupt. So if STM is sending a data means it will give interrupt and the data will be received. So this is why this pin is used. Okay. So now we will. So what next thing we are going to do is we are going to initialize this. We will serial begin. So this is for seeing the readings in our Arduino serial monitor. Okay. So serial dot print serial dot begin. So begin this UART communication. What is the baud rate we are going to use? This 11,005 1,15,000. So this is the baud rate we are going to use. Okay. So what next we are going to do is we are going to wait till this serial is available. Okay. So next thing is we are going to print that we are going to receive this LORA, right? So we are going to use this as an LORA receiver. So we are going to print this function will, when you compare with STM32, it will be programming for ESP will be very much easier. So for UART printing for UART communication, we have to create these lots of functions for STM32. But when it comes to the ESP32, we just give this serial print. So this will send my data in the UART communication so that I can see it in the serial mode. So this is a LORA receiver, right? Receive. Okay. Now we have to set this pins. So we have to say to the LORA that we are going to use this pins to the microcontroller. So we have this function as set pin. Okay. So now we will give this SS, RST and DAO 0. Now we have defined this pins. So next thing is we have to set the frequency. Okay. So we are going to use this frequency. So the frequency will be for the LORA frequency. It will be different. It will be different as per this location. So when it comes to Europe, it will be 866. When it comes to North America, it is 915 megahertz frequency. But we are in Asia, we are using is 433. Sorry, 433. Okay. So we have to begin this. We have to wait till this frequency is initialized. LORA dot of begin. So we have this begin function for LORA. So in this we are going to give us 433, which is for Asia. So it is E6. Okay. So now we are next we are going to get into this loop and we are going to wait till this LORA is initialized. Okay. Serial dot print. So I'm going to see it in this serial monitor. So I'm going to then we will add some delay. Okay. So delay of 500. Then when this program exits this loop, then it is known as the LORA is initialized. So then we will print this. We will see it in the serial monitor that LORA is initialized. Okay. Wow. Print L1 off. That's LORA set. Okay. Then the setup function is finished. So what is the next thing we have to do is we have to receive the package, right? So for that we have to create a loop function. So we will code it in this loop. So this when we write the code inside this while loop means it is going to run it repeatedly, like In STM32, you will add this inside the int main, you are going to add this void one like those. It is same similar to this thing. Okay. So what we are going to do is first we are going to create a variable which is a package size. So it is going to transfer the data in the package size only. So in package one. So package size is equal to, I have a function for LORA dot of. So for raising the package, so face. Or we have to mention, okay. Package. So this will receive the package. If this package is received, we are going to read this data. So we are going to create this if condition. The package size is so we will get into this loop. Then what we are going to do is we are going to print println of received packet. Okay. Okay. So what is the next thing is we are going to do is we are going to, now the packet is received, right? So now we have to read the data. So for that we have this so we have this function LORA function, which is we have to check whether the LORA is available. Okay. LORA dot of. So this will check my LORA is available. If this LORA is available, it will get into this loop. Then it is going to print our data. So I will put in serial monitor serial dot print of okay, new line. So this element mentions that it is a new line. Then I am going to get it in a character. So in character wise, I am going to read. We have a LORA function which is to read. So you have to do this LORA dot read. Okay. Okay. So finally, we are going to check this print this RSSI. So where this data is located. So it is going to say this our packet location. Okay. So I will print these things serial dot print dot. Then I'm going to print those addresses. Okay. So we have a function for it. LORA dot of packet or SSL. Okay. So it is in this small letter. Okay. So this is how we will receive the packages from STM using this LORA. Okay. So now we have finished this code. Now we will compile this. So what is this? Okay. Now we have to add these boards. I have already added. I have added this so node MCU 32S, which is mentions the CSP. Okay. So for if you don't know how to add this libraries means you have to go to this preference and you can see we have this you have to add this link in this additional boards manager URLs. Okay. So this link will be available in Google. So you can search for this link. So you can search in ESP32 board manager boards URL. You search in Google means you will get this. Okay. Then make it copy here and click OK. Then your package will be downloaded. Then you have to include this ESP32 board. Okay. So we have this ESP32 by Expressive Systems. Okay. So now we will compile this. So we have some errors. Wait. Okay. Wait for the code to compile. Okay. The code is compiled. It has no errors. Okay. So now we will connect the ESP32 board with it. Okay. So first we have to select this which port it is. So go to this port, and it is I have only one port. So this content. So it is content to content. So now I will import this code. Okay. Now we will get into this. So this is the code which we have developed yesterday, right? So we are going to send this data to this. Upload this code, and we will upload this code in this HTML also. So I will not. Okay. Okay, we are no errors, and we will compile this. Now the code is compiled, and we will get into this. The code is also uploaded in this ESP32. So now you can see the LORA is not initialized yet. So it is printing these dots till this LORA gets settled. Okay. Okay. So now we will get into this debugger, and we will start those processes. Okay. So you can see we have txbuff. We are going to send these values. So the process started. So we will reset this. Okay, I think. So first we will reset it, and we will wait for this LORA communication. Okay. So now you can see the LORA is set up. Okay. So what we have to next do is we have to configure this. Okay. So we will again reset it, and wait for this. So you can see our package is receiving. So every time I'm resetting this HTML2, so it is setting this package. It is like ABC. So what is we have mentioned here? Okay. So you can see we are sending this ABC one. So this is what it is sent. So you can. So this is how we are going to develop this temporary. We are going to set this temporary sensor reading all these reading to this ESP32, and ESP32 is going to read those data. Okay. So it is receiving continuously. It is receiving these data. Okay. Now we will get into this DST. Okay. So first we have to go to this DST server, and DST datasheet. So we have to know how this module is working. Okay. So we will. Oh. So we will get into it. So what are the things we are going to do is we will get into this DST. This is a digital humidity and temperature sensor. Okay. So what are the things we have to know first is how it is transferring the data. So how this one sensor is transferring both the data of humidity and temperature. So this is a sensor you can see. So you will have this 4 pins. One is not connected. and one is for VCC and ground, another one is for ground, and one is source. Okay. So you can see the measurement range for humidity is 20 to 90%, and for temperature is 0 to 15 degrees Celsius. And the humidity accuracy is plus or minus 5%. Like that. Likewise, it is plus or minus 2 for temperature. And resolution is 1. So it is going to send the data in 114. Okay. Okay. So what is the next thing we have to know is how these data are getting transferred. Okay. Now we will see this. So this is the overall communication process, how it is getting transferred. Okay. Okay. So now what is microcontroller want to do is the microcontroller will first it will give a logic 1 to this DST11 sensor, and sorry, it will start from logic 1 from it is going to first GPIO pin which is connected to this DST sensor sources. The first initial step is it is going to act as an input, and it is going to act as an then it is going to act as an output. Okay, so it is going to send the data. So why it is sending the data to DST sensor means it is going to data sends to the DST sensor to activate the DST sensor. Then the DST will send back the data. So we are going to again get the input from the DST. So we have to toggle those input and output between those which pin we have connected to the source of the DST level. Okay. So what is the process we have to do? So the first thing is this is a overall process. So first thing what it will do is the MCU which is a microcontroller will sense logic 0 and keep it for some milliseconds of delay, and it will pulse the line to logic 1 and keep it for some specified time. Then the DST sends out a response signal. After that the DST will sense a data. So next that what DST will do is then it will pulse up the line to the logic 1, and it will wait for some milliseconds. We will see that so what are the time period between these, and it will again pull down, and the data output will be C. So we will again it will go to the logic 1, and when this sensor pulls down the bus, then the data transmission will occurs. So we will see detail. Okay, in a detailed way. So you can see first we have to send these commands. So first I have to send this logic 0 to this DST11 sensor for 18. I have to hold this logic 0 for 18 milliseconds. Then I have to make those line to the logic 1, and I have to wait for 20 to 40 microseconds. Then the DST will send out the response. So we have to wait till this response takes a time of 80 microseconds. So we have to wait till this timing, and DST will pull the voltage to the high, and it will take the time for 80 microseconds. After waiting for 80 microseconds, it is going to send the data and start the data transmission. So this is how the data transmission is done. Okay. So what is the next thing you have to know? See is so DST responds to microcontroller. So you can see first it will starts to transfer the 1-bit data in 15 microseconds of time interval. Then the voltage length will be again it will be logic 1, and it will be the time period is 26 to 28 microseconds. So we have to wait till this time is completed. Okay, so we have to create this timer concept, and we have to create some microsecond delay, and the data transmission will get started. Okay, so how this data transmission is started is you can see it. So then it will the same thing. So then it will wait for we have to wait for 70 microseconds, and it will get into the data transmission. Okay. So I think this is enough. Okay. So this is how the DST will work. Okay. Now what we are going to do is we are going to create this DST sensor. Okay. So we will stop this LORA for a second. Okay. So it is not going to send the data LORA. So first we will configure this DST sensors. Okay. So what are the functions we have to create for the DST is so we are going to define here. Okay. So what are the functions first we have to do is we have to create this static of void. In this we are going to set the pin as an input. Okay. So we are going to make it as a set pin input. Okay. So in this inside this what are the things I am going to define is so you can get into this So inside this, I'm going to declare this GPIO of a type def. So I have to give this port number and a pin number. Okay. So which we will be defined already. Okay. So what is this? Define this GPIO of type def. In this, I have to give this GPIO of. So which GPIO I'm using, which port I'm using. Next, I have to give this int of 16t. I have to give this which pin I'm using. So we have this function in the all library. So by giving the port and pin, we can activate those pins. Okay. Then GPIO of pin. Okay. What is that? Then we will again we have to declare this as an output. So we have to copy this and so this is output. Configure the pin as an input and output. So we have to okay. So what is the next function we have to create is we have to read this right. We have to read the response and we have to read that data. So we have to first check the response. So for that static of 8 of t. Okay. So in this I'm going to mention it as a DST of 11 check response. So we are going to check this response. Guys, so what is this? Okay. So we are going to check this response. Then we are going to we have to read the data, right? So for that I'll create this read function. Okay. So DST of read. So these are the functions we are going to create. Okay. We will make this copy and we'll paste it here. Okay. So what is the first function we are going to create is it is for input. Okay. Okay. So we will get into the function. So first thing we have to do is we have to set these pins. So for that we have a function for in all library. So why we are using this all means because we have a LORA library in the all defined function. So the LORA library is built on this all defined function. So we are using this all libraries. Okay. So GPA of. So when it comes to the creating a project, so it will be much easier. Okay. And bug free. So I'm going to define this GPIO of init storage. Okay. So it is going to define my GPIO is equal to 0. So what is the next thing we have to do is we have to set this pin. We have to set this what is the mode and what we are going to use the speed. So these are the things we are going to set. Okay. Then we are going to finally initialize those port and pins. Okay. So next is what we have to do is GPIO of in this we have to do this pin. Okay, I'll make these things copy of it. Okay. So in this pin we have to give this which pin we are using. So GPIO of which we have already defined that. Okay. So next thing is we have to give us mode. We have to select this what is the mode we are going to use this pin. So first we have to set a pin as an input and we have to change it to output, right? So this is for input. So for input, we have to set this pin as an input. Okay. So GPIO of mode. This we are going to set it as an input. So it will be very much simple. You can give it directly. So this will set my GPIO pin as an input. So what is the next thing I have to do is I have to set this push pull function. Okay. So dot of go to this register pull. So we have already seen this. What is these registers are do and what are the things inside these registers. So only we are going to we are using this all libraries. So it will be very much useful. So both things you have to know. So you have to know this from this beginners and you have to know this advanced also. So when this advanced programming library will be understand when you understand this basic level of programming. What is happening in background in the back end of this functions. So for that purpose only we have started in the masterclass in this in register level, and now we are getting into while coming with project development we are getting into this all libraries. Now we can understand what is this function is going to do. Okay. Now we will give this as a no pull. Okay. No push or no. Okay. Then we have to initialize it. Okay. So GPA of init. Okay. In this we have to give this which port we are using. So GPA of X. So this is going to define, and we are going to start this. We have to say this address. Okay. GPA of init of structure. Okay. So these are the things we have to do for setting the pin as an input. So for output also we have to do the same thing. So I will make this as a copy of it. Okay. And I will. Okay. So here what are the things we have to change is just we have to change this to output push pull. Okay. Which will mention it define the pin as an output push pull. Next we don't need to configure this pull up register. So we will configure this speed. Okay. So what is the speed is going to be is for output it is speed at low frequency. Okay. So this will set my frequency in low, speed and low. Then the same thing we have to define these things. Okay. So now we have created this both the functions. Okay. So what is the next thing we have to do is wait. Okay. So what is the next thing we are going to do is we are going to read and we are going to develop the function for read and check response. Okay. So what is the first I'm going to create is I'm going to create this check response. So inside this check response, we are going to check these responses. Okay. So first I will declare a variable in the site of t. So in this I'm going to declare a variable of response is equal to, and I'm making this as 0. Okay. Then what is the next thing we have to do? So we have to go to this. So you can see where is this response. So it is going to send these bits. So we have to wait for 40 microseconds when it is logic 0, and we have to wait for. Wait, I will show it. Okay. This is 80. So you can see it. So 80 milliseconds. So we will create these delays. So for creating these delays, what we have to do? We have to create the timer, right? Timer function. So before creating this start tick read, I will create this start tick off. Start. Void of in microseconds, right? So I'm going to create a delay in microseconds. So unsigned of int of micro. Okay. So this how to create this timer function delay. We have already done this in the previous sessions. So you can refer to those timer videos. Okay, guys. So what is the next thing we have to do is we have to enable this clock for the timer 2. So what is the timer we are using is we are using the timer 2. So which will be connected in this APB 1 bus. So APB. In this, I am going to send the logic 1 to the 0. So this will enable my timer, right? Timer 2. So what is the next thing we have to do is we have to set this timer's prescaler, right? So timer 2 I have PS. Okay. So what is our prescaler? So what is our frequency? So our timer 2 is connected to the ABB 1 bus. So in yesterday's session we have set this frequency for peak clock as an 36 and timer 1 ABB 1 bus as an 72 megahertz. So for getting 1 microsecond of delay, what for 1 hertz of delay, what we have to do? We have to divide the clock frequency by 1 megahertz. That means we will get the answer 72 megahertz divided by 1 megahertz. Then we will get the value of 72. So we have to give the 72 minus 1. So because the microcontroller will add 1 to it by default. Then we have to create this timer 2. In timer 2, we will go to the control register and enable this counter on left shift of 0. So this will enable my counter. Next, what I have to do is I am going to reinitialize my counter every time and gets into this delay function. So it will be in the EGR register. Okay, in timer 2. So one left shift of 0. So this will reinitialize my counters and update the registers. Then I am going to initialize this count register as a 0 CMT, which is a count register. And then we will create a while. So this is already we have created this. So we will go faster. Okay. So timer 2. In this we are going to check this status register, right? So I am going to check whether this registers are updated. I am going to wait till this bit is get set up. Okay. Then I will create another while of timer 2. So we are going to count here. CMT. Okay. Now we have created this timer function. Okay. So we will make a copy of it and paste it here. So what is the next thing we have to do is now we will get into this check response. Okay. So what is the check response we have to do is first we have to wait for 40 microseconds. So delay of MS, US, right? What is the function we have declared? Yes, MUS. Okay. So MUS, MUS of 40 microseconds. So you are going to wait for 40 microseconds here. Then we are going to wait till this. We are going to check whether this the pin from this DSG sensor is low. So we are going to check this condition. So if we have a function for reading the pin. So it will be in all of GPIO of read pin. In this we have to give this what is the pin. So what is the pin we have defined as right. So we are going to use this PB of so we will define these pins. Where is this? Okay. So now we are going to read this pin. So we have to read this GPIO port and pin. Okay. So what are the parameters we have to give us? So we have to give this which port and which pin. So which port we are connected as? We are connecting this DSG sensor with which port? Check it. So it is connected in PB9. So we have to configure those PB9 port of PB9. So we will. So now we have to define this pins. Okay. So go to this define of. We have to define this DST 11 of GPIO. In this I am going to port. Okay. Port. So I'm going to define this as a GPA of, what is the port we are using? Pin is GPA of PB of 9. So that means port is B, right? So yeah, we have declared this function. Next is we have defined the pin, right? So define of DST 11 pin. Okay. In this I'm going to define the GPA of pin 9. 9. Okay. Now we have defined this pins. Okay. So now we will get into this check response. So where's this check response here? Okay. So what is the first thing we have to do is we have to give this which port we are using. So we have already defined this GPA of 11 port. So we will do this. And what is the next thing we have to give this pin? So DST 11 of pin. Okay. So wait. Okay. So we are going to check this if condition. If this check, what we are going to check is if this pin is low or okay. If this pin is low, then it will get into this loop. And what is the thing we are going to do is when you are getting into this loop, right? So you can see we have to wait for 80 microseconds when it is logic 0. So go to this and we are going to create this mus of 80 microseconds. So this will give me a 80 microseconds of delay. Then I am going to check this response. Okay. So I am going to check this pin. If it is high means I am going to give this load the response value as around 1. Okay. So I will create this if of same thing we are going to do. So we are going to check whether it is equal or not. So now if this condition is satisfied means I am going to give this response is equal to 1. Okay. So if not satisfied means we are going to give this response as -1. Okay. So these are the things we have to do. So what is the next thing we are going to do? Is we have to we have to wait for the pin to go loop. Okay. So same thing we have to check this. We are going to create this while. So we are going to wait till this pin is getting to loop. Okay. So same function, copy this and paste it. So this will wait for my pin to go low. Okay. Then when this pin is go low, then we will return our response. Okay. So these are the things. Right. Okay. So what is the next thing we are to do is we are going to create this function for read. Okay. So for that, what are the functions we are to do is first we create this int of 80 and I comma j. Okay. So now we will create this for. So j is equal to 0. Then j, because we are going to read this 8 bytes. So j is going to run until this condition is satisfied. So j of this. Okay. Now we are going to wait till this pin is go to the I, because we are going to read the data from there. Okay. So we will copy this same thing. Okay. So inside this we are going to wait till this pin is getting into I state. Okay. So okay. So what is the next thing we have to do is when this pin is high, we have to wait for 40 microseconds. Okay. 40. What is the next thing we have to do? We have to check if the pin is low. So for that we have already Okay, to this, right. Make this copy and paste here. So this will check my pin is low. If this pin is low means it will get into this loop and we will read the data. Okay. So how I'm going to read this, I'm going to first I'm going to write 0. Okay. If the pin is high, I'm going to write 1 to it. Okay. So 1 left shift of 7 minus j. So this will write 0 to it. Okay. So if this condition is not satisfied means what is else we have to do is we are going to write 1 to it. So I is equal to I of 1 left shift of 7 minus j. Then we are going to write here 1. Okay. So what is the next thing is we are going to do is we are going to wait till this pin is go to the loop. Okay. So for this we have already created this function while off. Copy this and paste it here. Okay. Then we will return this I. Return the I value. Okay. So this is how we will create this read function, and we have left the only one function left. So what is it is we have to create this start function, right? So for starting we have to set the pin as an input and pin as an output, and after some delays we have to switch it to the input, right? So for that only we have created these functions. So I'm going to create this static of void of dst 11 start. Okay, void. So this is our function. Okay, so first we will declare this. Declare this here. Okay. Okay. So what is the first thing we have to do is we have to set this pin as an output. The first initial step. Okay. Output. In this what we have to give is we have already defined this DST11 port and pin. Okay. So this will set the pin as an output. Okay. So what next we have to do is we have to pull the pin to low. So for that we have this all library function which is GPIO, right? Like in the Arduino, like the functions in Arduino. Okay. Right. So in this again we are going to write the logic 0 to this pin. Okay. So this will write the logic 0 to the. Okay. Then we have to make for the delay of 18 milliseconds. So we have seen it in the data sheet, right? So it will be 18 milliseconds means it will be 18,000 microseconds. So we are going to wait for it. Then again I am going to write this pin to the logic. Logic. Okay. So what is the next thing we have to do is we have to wait for 20 microseconds. Delay of US of 20 microseconds. So this will next this will read my data, and next what we have to do is we have to set this pin as an input. So for that purpose we will copy this one, we will make it as an input. Paste and okay. Now we have completed this start function. Okay. Now we will get into the main loop. So we will get into this live, right. So it is going to send the 40 bit of data. Okay, so what are the things it's going to include is humidity and temperature information to the MCU. So user will choose to read it. Okay, so what are the data we will get is you can see here. So you can see here the data format is, so 8 bit of integral humidity data, 8 bit of decimal humidity data. Likewise for temperature and temperature data, so you will get the integral and decimal data. Then finally we have an 8 bit for checksum. Okay. Oh. So for this we have to create these all the, we have to declare these all these functions. Okay. So I will make so we have declared this RH byte 1, RH byte 2, which is integral data, decimal data for humidity, and here we have an integral data and decimal data for temperature, and some data and humidity direct data and temperature data. And we are going to store those values in these float values, temperature and humidity. Okay. So what is the first thing we are do is get into this loop and create this DST 11 start. Okay. So this will start my process. Then I'm going to check this right. I'm going to create another variable which is presence. So we are going to check the response in this presence only. Okay. So uint of 8 of t. So in this I'm going to create a presence. So this is going to give my response data. Okay. So inside this I'm going to declare this presence is equal to DHT 11 of check response. So this will going to check my response. Call those functions. Then RH byte 1. In this byte 1 I'm going to read this first data, which is integral humidity data, DHT 11 of read. Okay. So we will make this copy. Then again RH data, RH of byte 2. So in this, again we are going to read the second decimal data, and now we will declare this temp byte 1, then temp byte 2. So what is the data we are going to read is we are going to take the data as an integral data as an real time data. Okay. Then we have to add this sum also. Sum is equal to read the data. Okay. Now we have read this 40 bits also. Then we will assign those values to this values. Temp is equal to TMP of byte 1. Okay. Then RH is equal to RH of byte 1. So the integral data are we are going to use. Okay. Now we will declare this temperature is equal to float of temp. I'm going to store this values in this humidity is equal to FLVT, float of RH humidity. Okay. So these are the things, and we will going to create this. We have a delay. We have to create, we are going to give this 1 second of delay. Okay. So we will have this function for a milliseconds delay in this library in for all. So this will create a 1 second of delay. Okay. So these are things we have to do for reading this DSD sensor. Okay. So we will first compare this, and we have some one error. Okay. Wait, we will check it. Timer 2. Where is this timer? Now we will compare this. Okay, now we have no errors. Okay. So guys, this is how we will upload this code, and now we will see this. Now what we are going to do is we are going to upload these codes to it. So we have already disabled this LORA. So go to this output and so we going to check this these values, right? So I will add it in watch. Okay. Now we will try to compile it. So you can see in our my room temperature is 30 degrees Celsius and my humidity is 79. So I will now you can see I have holding this sensor. So you can see my humidity is changed and temperature is also changed. So this is how we will configure this DHT sensor. So guys, today's class is over. We will meet on next session. In next session, we are going to get into this soil moisture sensor and we are going to do some little bit configuration in ESP32 and we will send these data to that. So in coming in last 5 sessions, we are going to get involved in these projects. So this is why we are learning these soil sensors. We are going to create a project using these sensors. Okay, that's so guys. Thank you for the today's session. We will meet on next session. Thank you.